Hello students, today I am with my second video of part 1. So as in my previous lesson, I have already told you that we will be starting with the fourth content in this video, that was the 4 basic characteristics of particles of matter. So students, I have basically divided this content into 2 parts because it was quite lengthy, so I had to distribute into 2 videos. So I will be posting 2 videos in combination of both, right? They will be in continuation. So I would prefer you to watch both the videos to study 4 particles or 4 characteristics of particles of matter. Starting on with my topic, the first very characteristic is the particles of matter are very small. Now in the previous video we had learned that what was matter. I'll take 5 minutes for revision. We had already learned what was matter. Matter was something that has space, that occupies mass, right? Secondly, we learned that what is matter made up of. So we had learned that matter is made up of very small particles called as atoms. And all we know by our previous knowledge that atoms are something which are not visible with our naked eye. They are the invisible structures, right? So obviously as they are invisible, that means they are very small. So therefore here comes this characteristic that matter of particles are very small. Now the question comes that by now we know that these are atoms and atoms are smallest in size, so they are the smallest, very small particles. But the question is, when the matter was being studied in detail, how did the scientists came to know that the matter is made up of particles which are very small? So to learn that, we need to understand an activity. So that is why I have mentioned that this can be proved by an activity of potassium permanganate crystals. What is this KMnO4? Did we do this KMnO4? In the previous video also. Potassium permanganate is chemically symbolized as KMnO4. How do we derive this chemical formulas? I will take a separate video on valencies and show you that how these chemical structures are built. But for now, you just need to understand that potassium permanganate is chemically symbolized as KMnO4. So we had learned this in previous also, where we had shown that there were beaker where we had dropped KMnO4 crystals, and slowly and steadily the water retains the purple color of the crystals. This has shown that there are some particles present in the matter which intermix with each other, right? So this is how the particles of matter are very small, will also prove by this activity. Let's see how. Now see, KMnO4 crystals which are purple colored, we all know that they are purple colored crystals. What did we do? We dissolved them. Where did we dissolve? In the water. We dissolve them in the water. Water is what? Water is obviously a colorless liquid, right? It's a colorless liquid. I'm sorry. So water is what? Water is nothing. It's a colorless liquid present in the beaker. Now in that colorless liquid we had added purple colored potassium permanganate crystal. Thereby what we will see that the water has turned purple colored. The water has turned purple colored. The purple colored crystal spreads and mixes in water. These purple colored crystals have spread and got mixed in the water. Now, how can this purple colored activity show that the particles of atom are very small? Now I will tell you. Have you ever seen or have you ever dropped an ink anywhere? Usually in schools, many of us have done this naughtiness when we drop ink somewhere or the other just to play. So yeah, when do you ever see an ink and you drop it anywhere, it immediately spreads its blue color all around. Similarly are these potassium permanganate crystals, which when added in water, they immediately spread their purple color into the whole beaker. This shows that the particles of KMN of this matter are actually very small, that they mix very quickly, right? This is a fact. Anything which is smaller in size mixes very easily and quickly than the which are bigger in size. We see it in our daily life also. When we mix two things which are very tiny, they mix very fast, they mix very easily. But the things which are not that small and they are heavy in size, they take a lot of time to mix. So thus this quick intermixing of the particles of matter shows that the size of KMnO4 particles are very, very small. So hence I am clear with the first point which I had made you understand, that the particles of matter are very, very small is the first characteristic of particles of matter, and this we have shown by the KMnO4 activity, in which the particles of both KMnO4 and water have intermixed so quickly for the even spread of purple color in the water, showing us that the size of the particles is immensely small, that helps them to mix in seconds, right? So this is the first activity, first point, first characteristic of particles. Moving on to the second characteristic, the particles of matter have spaces between them. What does this shows? Now if you take the previous example only which we were doing, the KMnO4, right? I told you that the particles are small, very small in size, so they get intermixed very quickly, right? I am saying this word, so they get intermixed very quickly. This is the first thing you need to understand. Secondly, in my previous video I had decoded an example of a building and an attacker, where I had mentioned that the people, they enter inside the rooms and hide themselves from the attackers. So when the attackers come and see from the outside, they do not see any people. Why? Because the people have already gone and hidden inside the rooms of those buildings. Similarly, it happens here. When we take a beaker, mix two things in it, after some time we will not see the thing which we had mixed. We will not see that solute. For example, in sugar and water only, we will not be able to see that sugar in that water after some time. Why? Because that sugar particles have gone and hidden inside the water particle spaces. That means the particles of water had certain spaces inside them where the particles of sugar have gone and mixed. So that is what I am trying to tell you. So this intermixing also shows that they have some spaces between them. It's very clear. किसी भी चीज़ को गायब होने के लिए या छुपने के लिए एक जगह चाहिए होती है. जब तक उसको वो जगह नहीं मिलेगी, it will not hide. राइट, सेम सिचुएशन यहाँ पे है. अगर वो उसके साथ मिक्स हो रहा है, इफ इट इज़ नॉट बीइंग विजिबल, तो दैट मीन्स इट हैज़ गॉन एंड हिडन इनसाइड द space. This proves that the particles of matter have spaces between them. Let's prove this also by certain activities. Now, making of tea, coffee or lemonade. This is the very basic activity I have taken to explain this concept. How do we make tea? Whenever, if you've seen, we take a vessel, we add water into it, and then we add the tea. When we raise on the flame, the tea and water get mixed and the color of tea particles are seen in the water. Same happens with the coffee, same happens with the tea, and same when we infuse lemon into the whenever we infuse lemon into the water. If you have ever made lemonade, you take a glass of water, you squeeze lemon, the droplets of lemon go and quickly dissolve inside the water. That is what happening there also. The quick dissolution itself says that it is intermixing, and meaning of intermixing means that obviously there is a space between them into which the particles are going and settling. So this is very direct example of proving tea, coffee or lemonade, right? Now, the activity second, this you have to understand with a bit of mind. The first one was very simple, that the tea, coffee, lemonade, whatever you take, when you mix the two particles, they get intermixed very quickly. And intermixing shows that there is obviously a space between them where the particles of tea, coffee or lemon are going and hiding in the particles of water, right? Now this activity will clear all your doubts if even left till now. Mix 50 grams of sugar into 50 ml of water. So what I have done is I have taken equal quantity, 50 ml kahi I have taken water, and 50 grams sorry, I have added sugar into it. Okay, you can see the water level here and the water level here remains same. Even after few minutes, the water level in both the beaker remains same, while sugar here was present in the bottom, while sugar here is not seen. There are no sugar molecules seen and the volume of water is same. This is what I have mentioned here, right, in the corner, that there are no sugar molecules seen in this beaker and the volume of water remains the same. Now why hasn't the volume increased? In spite of adding 50 grams of sugar into 50 ml of water, why did not the volume of water increase? This happens, no, if we take a bucket, if we take any vessel only, we add two things into it. The already first thing is there in it, and then on the top of it we add second thing. Usually what happens, the volume of that vessel is increased. If it was half vessel, that time on adding of certain thing it becomes full vessel. Like if I take a daily example, you might have seen, whenever you try to dissolve anything in water in your kitchen, you see that their level of water rises, but this rise you will not see in those things where the thing with the water is mixing, right? Like sugar solution, salt solution, and many other things which get dissolved in water, like tea, coffee. We do not see any rise in volume. It is just because those solute particles go and mix with the water. They go and hide in the spaces between the water molecules already present. Now whereas I taken this word molecules, as you remember in the previous video I had told that atoms combine to form molecules. So that is what has happened. Now you can say call it as atom also, but just to clear your confusion, for example, tomorrow if anybody says that it is entering the spaces between the molecules, so you should not get confused that ma'am taught us atoms and whereas this molecules come from. This is very genuine, that atoms will combine to form molecules, so the spaces will remain the same. So coming on the concept, same was happening. The sugar particles have gone and mixed inside the water particles. So this shows again mixing has occurred. So what will happen if mixing has occurred? That means there is space between the water molecules. And why hasn't the volume increased? Because whenever there was already a space between the water particles into which the sugar particles have gone and settled, they did not occupy any other extra space. That is why the volume of the water has not increased. This proves that the particles of matter have spaces between them by default only, right? They already have spaces in between them where the particles of other matter come and mix with it. Clear? So this is about the second property of particles of matter. So by here I have covered two properties of particles of matter. One, the particles of matter are very, very small by the activity of KMNO4, and second, that the particles of matter have spaces between them by the activity of tea, coffee, lemon into water, and secondly sugar into water with no increase in its volume. Right? These are all NCERT based activities, and plus I have taken some extra points to explain you better. Now coming on to the third property, particles of matter are continuously moving. Now please let me tell you that from here the first two were very easy, and even the last property is very easy. This third property it is a bit lengthy also, and you need to put your full focus over here, right? So particles of matter are continuously moving. Now we have seen what we have studied by now. Firstly, that they were very small. Secondly, they got intermixed into each other. Thirdly, they had spaces between them. These three concepts we have studied by now, right? So when they are intermixing, that means they are showing some movement. ऐसा तो है नहीं है कि वो बिना हिले एक दूसरे से मिक्स हो रहे हैं. इवन इन द किचन व्हेन वी मिक्स समथिंग वी स्टिर देम, डोंट we take another vessel or we take a spoon and stir them, we make a movement in them and then they get mixed. कभी भी पानी में चीनी घोला हो या नमक घोला हो तो हम हमेशा उसको हिला के घोलते हैं, and that is what I'm trying to explain, the significance of movement, right? So particles of matter are moving, they are continuously moving, that is why they go and mix very quickly. So this is shown by two activities, burning of agarbatti and addition of copper sulfate crystals into both hot and cold water. Do not worry, I will take one by one both the things. Firstly, burning of agarbatti. Now incense stick that we call in English. So have you ever lit an agarbatti? If you have ever lit it, you will experience that when you lit agarbatti in the room or like in a closed space or you will immediately start feeling its fragrance. Within a span of seconds you will feel its fragrance. Why does this happen? Same reason, because the agarbatti also had particles as it is a matter. To that agarbatti we provided heat, right? We lit it with a matchstick. So what did we provide? We provided with heat. Heat was provided to the agarbatti. When agarbatti was lit, the fragrance of agarbatti went and spread in the whole room. So friends, this was very simple thing, that agarbatti was when lit with the matchstick, when heat was provided, its fragrance spread into the whole room. I will come to the actual concept. I have highlighted this mark heat. If you can see this star mark I have placed in front of heat, so you just need to lay more focus on it, because the actual concept will come from this only. But for now, this whole activity means one thing only, that the particles of agarbatti were ignited by the heat, they were lighted. If you do not understand the meaning of ignited, simply it means they were lighted, right? When they were lighted by the heat, they spread into the whole atmosphere and got mixed into the particles of atmosphere, thus spreading its smell. We will take this activity in our further videos also, so please do not jump into any conclusion for this, because detailed explanation for this you will understand in diffusion. I have not taken it here just not to confuse you, so do not get confused. We will take up in the next part. For here you just understand that it is an activity to prove that the particles of matter are continuously moving. Obviously they are continuously moving, that is why they went and spread so quickly, such that the essence of the incense stick has come to our nose, right? The second activity, if we study, you will see the activity is copper sulfate crystals. Now copper sulfate is the chemical, and I may tell you that these are blue colored crystals. We symbolize copper sulfate as CuSO4. Please remember one or two chemical names for now. I will be taking up another video on the chemical names, right? So please understand it for now. Copper sulfate crystals, CuSO4, these are blue colored crystals. Now we have added these blue colored crystals to both hot water and cold water. You can see on this side we have cold water, and on the other side we have hot water, right? So when we have added blue colored crystals in cold water as well as in hot water, the water has turned blue in both the cases. Why? Because same concept, the particles might have intermixed. How did they intermix? Because they had spaces in between them, and then when they had spaces in between them, how do they mix? They move towards each other and mix. So three parts have been proved here only, that they have spaces between them, they are very small to get mixed very quickly, as well as they are continuously moving. That is why they go and get mixed with each other. Otherwise बिना मूवमेंट करे किसी भी चीज़ को मिक्स करना, it is not that quick. But the only thing you have to notice here is again a highlighted mark which I have shown here is this only. This highlighted mark I have again shown, that in hot water the reaction is faster you can see that hot water has shown faster reaction, right? Now this is very important. In the previous part also I have highlighted on heat, in here also I have highlighted that hot water is showing faster reaction. Why? The reason I'll be continuing in the next part, but for now you need to just remember that heat has certainly very important role to play with the movement of particles, right? By now I have summed up three basic properties. The first one was very small particles, second one was they have spaces between them, third is they are constantly mixing, and all the three are just because they intermix with each other very quickly, which shows that they have spaces between them and they move towards each other, right? Any confusion for it, please let me know through the comments, and continue the second video for the continuation of this characteristic as well as for the fourth characteristics. Thank you very much.